So in the following table, there's a kind of an example of a bivariate table. Chi-square is always tabulation. It's only table tabulation. That's it. And it always involves a table. In this case, a bivariate table. And there are some things we have to remember about the table, right? So the vertical are always the columns, and this is the vertical, and the columns are always the independent variable, and the independent variable is always x. Right? So columns are always the independent variable. If the columns are always the independent variable, then going across the rows are always the dependent variable. And we know that that is a y, right? So it's pretty easy. Rows are y, and columns are x, right? So as we think about this, as we set up a table, and this idea of the f expected, it's all about the tables, right? So if we have a table here, which you have in your slideshow, the f expected is always row marginal times column marginal divided by n, right? So in the chi-square table that you have following this slide, it is basically high, low, and the high-low would be the column, and the row is marital status. So you got married, unmarried. Let's call it single, right? And then you have totals, right? And on the bottom you have totals, right? So for married, there is 25, which gives us a total of 50. And for unmarried, the same thing, 25, and gives us a total of 50. If we take the total of the columns, it's also 25, 50, right? 25, 50, right? So, but let's think about how would we come up with the f expected for each one of these, right? So f expected is row marginal times column marginal divided by n, right? So our total is 100, right? That's our total for our table, right? So that is n, right? The total for the table. But let's come up with this f expected, right? The f expected for our first 25. And it says that it's row marginal times column marginal, right? So the row marginals are the totals at the end of the row. So for this particular 25, and let's call this 25A, its row marginal is 50. Its column marginal is 50. If we were to determine f expected for this A, it is simply 50 times 50 divided by 100. That gives us our f expected for, let's call this A, right? This is quite a simple table. If we were to do the f expected for this one, let's call it C, it's the same thing, right? It's row marginal, which is 50, times column marginal, which is also 50, divided by n, which is 100, right? Okay, so it's kind of a simple explanation of row for determining F expected. Now we're going to do an example which will speak more to the simplicity of this.